You are interested in finding out if gender is related to the hand that a person considers their dominant hand, and so you take a sample of 100 individuals and categorize them according to each variable, male or female, right or left-handed. We have the table giving our data along with some totals, and we want to determine if handedness is dependent on a person's gender. When we're doing a test of independence, our null hypothesis is that the two variables are independent of one another, and our alternative hypothesis is that there is some dependency among those variables. Now, to find our chi-square test statistic, we need all of the expected counts, which are what would be expected if the null was true and we had an independence among these two variables. We find our expected counts by taking a row total times a column total over the total sample size. So for males that are right-handed, we have a row total of 52, a column total of 87, and a total sample size of 100, giving us an expected count of 45.24. For the next group, males that are left-handed, we have 52 times 13 out of 100, giving us 6.76. And if we continue for the other two categories, for the females under both uses of the hand, what you should find is that you get 41.76 and 6.24. Notice all of our E's, our expected counts, are at least 5, so that our sample size was large enough for our conditions to be satisfied. Our chi-squared test statistic now then is where we take our O minus our E and square it divided by our E. We'll have four terms here, 43 minus 45.24 squared over 45.24 plus 9 minus 6.76 squared over 6.76 plus 44 minus 41.76 squared over 41.76 plus 4 minus 6.24 squared over 6.24. And so that will give us a test statistic of 1.777. Degrees of freedom is number of rows minus 1 times number of columns minus 1. We have 2 rows and 2 columns, so 2 minus 1 times 2 minus 1 gives us 1 times 1 for degrees of freedom of 1. Looking at our chi-square table in row 1 for 1.777, we find it's between the value 1.64 and the 2.07. And so our p-value is bounded by these values at the top here, our right tail areas of 0.15 and 0.20. So if we get a p-value between 0.15 and 0.20 and we use a 5% level, we see our p-value is bigger than an alpha of 0.05. So with a large p-value, we are unable to reject the null. So what we'll say here is that we do not have significant evidence that our alternative is true, which says that gender and handedness are dependent. So based on our sample of 100 people, we're not able to say that if we were to look at the whole population that we would find any dependency amongst the person's gender and the hand that they wrote with, or was their dominant hand.